Well, my name is Joshua Smith. I'm with MakerGeeks.com, and we sell 3D printers, 3D printer filament, and do manufacturing here in Springfield, Missouri. Well, I started manufacturing our own filament. There wasn't a quality control issue. There wasn't really even a price point issue. It was just the fact that we were buying everything that we were getting from China, as is everyone else in the world, and we thought we could do it ourselves. So making filament step by step is you start with a raw resin, PLA, ABS, whatever it is. It's usually granulated. The resin is always either clear or white. It doesn't come colored. You put it into a blender if you're going to mix a pigment or an additive with it. The additive could be anything from like a structural integrity type additive that might give it more strength or impact resistance, to magnetic properties, or just color. So if you want blue, you add blue pigment to the resin. Turn the blender on, it blends, and now you have blue resin. So from there it goes into a drying process, usually about a 2-hour dry at anywhere from 60 Celsius to 80 Celsius. This is really important. It's kind of the one part that you can skip if you're trying to make filament really quickly. And I think that's why people get filament that pops on them or jams on them. It's because they didn't take the time to dry it. Then it goes into a single screw extruder, which is probably one of the most common manufacturing tools in the world. So once it comes out of the single screw extruder, which is where it's heated and mixed and extruded into a solid monofilament, then it goes into a warm or hot water tank, which gently cools it, and that's how you get round filament. If you ever have oval filament, the reason you have oval filament is because they had their water temperature at the wrong temperature for whatever they were running. So if you have your hot water temperature set right and your nozzle temperature set right and the resin is set right at the right temperatures, you come out with perfectly round filament. So from there it goes into a cold water tank, and it runs through that for maybe 20 or 30 feet, and then it starts getting wound and put onto a spool. So the way that you get either the 1.75 or the 3 mil or the 2.85, and I thought this was interesting because I thought it would be a different die that would come out at a different size, and it's actually not. It's a tractor system, and it pulls that filament out of the extruder nozzle at a constant pressure. And so if you want 1.75, you pull faster. If you want 2.85, you pull slower, and of course that's going to make that filament smaller or bigger. So how you control the tractor system is how the diameter comes off the machine. So if you have a consistent diameter, then you know you have your process right. And we have a laser gauge that it goes through in real time that monitors that. So if I start seeing that jump up and jump around, I can pull the filament off, and fix whatever the problem is. But as long as that's running, right on, you know that your process is right. And then we print with what we do. We print probably upwards of 100,000 hours a year on our machines, and we still print probably 30 to 40,000 actual printing hours every year, and we only use our filament. So if there's a problem, we're going to find it. So this is another reason why we kind of know we're the only ones that are doing it. This is a major manufacturer of these extruders, and they couldn't get visas to come over, so nobody came to train. So it shows up, it takes up that whole space. So I put it together, I assembled it, wired it. It's an odd thing to Google this because it's like this void of information because people are doing it. It's just like people build jet engines, but Boeing doesn't blog about it. Well, people are doing this in China, but they're doing it on $100 million levels. They don't blog about it. So it's like a thing you got to figure out, and it really is the temperature of. There's 4 zones in the extruder. Each zone has to be the exact right temperature in those 4 zones, in the right sequence for the speed and the traction speed, and then each water tank has to be exact. It's that precise, and it has just been like this constant battle of like prayer, and then you get an answer, and then you go back and you change something, and then you're sitting at home and it's like, oh yeah, that's the answer. You go back and try it. It will be science. There will be a time when it is like desktop printing where you push the button and it's always that number. But for right now, it truly is that. It's an art form, and you've got to be able to kind of flex with that.